Hello friends, welcome you all in my YouTube channel. I am Dr. Mohammad Sirajul Faisi, Assistant Professor, Department of Chemistry, LS College, Muzaffarpur. Today in this video, I am going to explain about coordination chemistry. Look at this picture. This is a genius guy, Alfred Werner from Switzerland, University of Zurich. He is the father of a structure of coordination complex. He got Nobel Prize in 1930. So let's just start with the basic because basic is important in chemistry. Look at the Lewis acid and bases. You know that what is the meaning of Lewis acid. A Lewis acid and Lewis base, you have to define it. A Lewis base is a molecule or ion that donates a pair of electrons to make a bond. For examples, ammonia, it is here, OH2 means water, chloride, one lone pair, chloride, one lone pair. It has two, but one lone pair is sufficient. Electrons in the highest occupied orbitals, we call this HOMO, of a molecules or anion are the best Lewis bases. Lewis acid is a molecules of ion that accept a lone pair of electrons to make a bonds H plus, cobalt 3 plus, cobalt 2 plus, metal N plus. Molecules or ion with a low lying unoccupied molecular orbitals. Low lying unoccupied molecular orbitals. So this is the basic. You should know what is the difference between HOMO and LUMO. I already make many videos on the basis of HOMO LUMO because that one is very important. What is the meaning of HOMO and what is the meaning of LUMO? Of a molecules or cations are the best Lewis acids. Convention in writing the structure of coordination compound. A coordination compound is a neutral species. That is important. Concentrate on neutral species consisting of a coordinate complex and uncoordinated ions required to maintain the charge balance. So bracket, you see this one is this big bracket. Everywhere in inorganic chemistry you will find this one. So keep it in mind. Are used to indicate all of the composition of the coordinates compound. Right friends? Remember this bracket? It's okay. Now the symbol for the central atom metal of the complex is first within the brackets. So friends, species outside of the bracket are not coordinated to the metal but are required to maintain a charge balance. So this one is important. Just keep in your mind bracket, bracket, bracket. So ligand substitution reactions. For some complex ion, the coordinated ligands may be substituted for other ligands. Right friends? Complexes that undergo very rapid substitution of one ligand for another, we called it labile. What? Complexes that undergo very rapid substitutions of one ligand for another are termed labile. Complexes that undergo very slow substitution of one ligand for another are termed as inert. Look at here. This is your nickel, hexahydrate. This one is water is ligand here. How many ligands? 6 ligand. What is the charge? 2 plus this charge on nickel. This is substituted by the ammonia. How many ammonia? 6. So all water change with the ammonia. Charge same, only 6 is also same. In place of water, now ammonia is here. Metal is same. So what happened here? All water is replaced by ammonia. So Werner explanation of coordination complexes. Metal ion exhibit two kind of valence. That is, one is primary and second is secondary. So primary, secondary, primary, secondary, primary, secondary. That is important. Just remember it. The primary valence is the oxidation number. What? Primary valence is the oxidation number. Positive charge of the metal, usually 2 plus or 3 plus. That is the primary valency. Primary valency is the charge on metal. The secondary valency is the coordination of atoms that are directly bonded, coordinated to the metals. Coordinated to the metals. How many coordination? This. So, primary and secondary. The secondary valence is the number of atoms that are coordinated, directly bonded or coordinated to the metals. Now, friends, right, the secondary valence is also termed as coordination number. That is the important. Just remember, most of the time, people they are not caring such type of peculiarity and such type of words, so they are facing problem in examinations. They forget what is the meaning of primary, what is meaning of secondary. Nothing. Primary means primary, where it says you look at the charge, and secondary is the coordinations number of metal in a coordination complex. So examples of coordination complex. This is the coordination complex. Why? Now you look at how many ligand is here and which type, what is the ligand, where is the central metal. So this is your central metal. And ammonia is here ligand. How many ligand? 6. This 3 is for the ammonia. Initial for at initial stage of chemistry, people are in all the time confusing. This ammonia formula, nothing else. It acts as a ligand, and this is the how many, the 6, and this is the close. This is the coordination sphere, and it is the outside of coordination. This 3 is different. It is not coordinated to the, but it is balancing the charge. So what is the atomic composition of the complex? So what is the net charge of the complex? Just remove here this 3 Cl minus, then 3 positive charge will come. How do we know the charge is 3 plus on the metal? 3 plus is required to balance the 3 Cl minus. Very important. 3 plus is required to balance the 3 Cl minus. The primary balance of cobalt NH3O6Cl3 is 3 charge on cobalt. The secondary valence of cobalt NH3O6Cl3 is 6 ligands. So this is the secondary and this is the primary. This is the primary, this is the secondary. Just remember it. Primary, secondary, primary, secondary. Okay. Structure of coordination complexes. The ammonia complex of cobalt 3 plus. How did Werner deduce the structure of coordination complex? Composition, ion released, color. COCl3, 6NH3. 3 free and Cl minus. The color is orange yellow. COCl3, 5NH3. 2 free Cl minus, purple color. COCl3, 4NH3. 1 free Cl minus, green color. Here free means it is not bonded to metals. COCl3, 3 ammonia, O free, 0 free, Cl minus and green color. So look at here. COCl3, COCl3, COCl3 all are same. What is the difference? 6 ammonia, 5 ammonia, 4 ammonia, 3 ammonia. What is the difference here? 3 free Cl minus means 3 chlorine is not bonded to ammonia. So how many 6 ammonia bonded to chlorine? Concentrate here. 2 free Cl minus means 1 chlorine is bonded to chlorine. That's why where is the 3 chlorine is here, but 2 chlorine there is a color is different. 1 free chlorine and 0 free chlorine. That is very important. Initial stage people not understanding this 3 free Cl minus 2 free, what is this? So concentrate here, we have the 3 chlorine in each compound, but they are different color, means on the basis of color maybe all chlorine is not free and all chlorine is not bonded. Okay. So logic, Cl minus is not the coordinated sphere, ammonia is in a sphere. Compound 1, COCl3 6 ammonia, it means CONH3 COO6 3 plus, because this 3 free Cl minus. Now it is free. 3 free Cl minus ion. Conclude. COCl3 5 NH3. CONH3 whole 5 Cl 2 plus 2 free Cl minus. 2 free Cl minus. And coordination sphere, you see here is difference. Now Cl is attached with the cobalt, but here no. That's why there is a difference in color. Compound cobalt 3 for NH. Now you see 1 Cl is free, 2 Cl inside. So 1 free Cl minus. Now COCl 3NH3, 3NH3. You see 3Cl is inside, no free Cl minus. So friends, you understand what is the meaning of free. Okay. Coordination complex three-dimensional structure. You see COCl3 6NH3, all chlorine, NH3, 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 NH3. This one is the ligand and this is the for balance. So CH3 5NH3, situation is like that. 4NH3, you see 2 chlorine is bonded. Here 1 chlorine is bonded, 2 free, 2 bonded, 1 free. Here no bonded, 3 free. Here 1 bonded, 2 bonded, 1 free. But in different way. You see this is a cis and this is a trans. Isomers. So bond towards you, this one, and bond away from you. This is the designations for this. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.